The broadcast is now starting. All attendees are in listen-only mode.
Okay, we're going to go ahead and get started here. Good afternoon, good morning, good evening, wherever you may be. Thanks for joining us today. This is the Rail Design Workflow. The majority of this presentation is going to be in Civil 3D. We're going to touch briefly on some of the other Autodesk platforms. And really that's more to bring information into Civil 3D or to export information out of Civil 3D that can then generally be used for other disciplines. My name is Ben Wardell. I'll be doing this presentation. I'm a professional engineer here in Denver, Colorado, and I'm a technical marketing manager for civil infrastructure here at Autodesk. So general guidelines on these webcasts, we do these about twice a month, and generally they're the first and third Wednesdays of every month, so we've got another one coming up in 2 weeks. The goal of these forums are to be able to present content and information to the users, as well as we as the developers and the marketers can get together, kind of show the things that are going on that are important, and then you can provide feedback and information that and content that you'd like to see as well. Coming up next week, we're going to be going over what's new for InfraWorks 2019.2, and Ara Ashikan is going to be providing that demonstration for us. A lot of really cool features that are coming up in InfraWorks, particularly on the bridge design side of things. So that'll be coming up on October 3rd. So look for that in the InfraWorks community site, on the civil community things, a handful of places that'll come out as well. You can look for that on LinkedIn and other forums as well. And as always, really do want to encourage any kind of, if there are any topics or ideas that you have as the users, please present those. And in fact, if any of you have those now, you'll notice on the GoToWebinar, you have a little dialog box on the side there where you can input any kind of questions. We encourage questions throughout the presentation. We'll try and leave some time at the very end for questions. But if any of you have any thoughts or ideas or topics that you would like to see demonstrations for or additional information on, you can do that now or during the course of the presentation. And I want to direct everyone's attention as well to the civil community site. There you'll see signups for any sort of upcoming webinars, as well as news or tips and tricks, things that are going on in that regard, as well as any of these broadcasts. All these broadcasts and these webinars will be posted there as well. And so kind of get to that point here. So hang on just a second, I'm going to revise a couple of these things. And right now, have a couple of poll questions that I want to initiate. I also want to introduce Annie Fan. She is going to be helping us out on the Autodesk side as well. She's doing everything behind the scenes that make this whole webinar presentation actually happen. So I want to thank her. Thank you to Annie. Hopefully she's listening as well.
Yes. Hi everyone. Thanks.
Great. And so Annie, I'm going to launch the polls now. And so since she's more familiar with this than I'm going to need her help in order to make this happen. So we're going to ask a couple of poll questions, and these are interactive. So we'd like all the users to be able to input any kind of questions that you've got. So I'm going to launch the first question. And the question is what kind of work do you do with Civil 3D? And so go ahead and we'll leave that open for a handful, just for a few seconds, and get an idea here of what you guys are using Civil 3D for mostly. We'll leave that for another couple of seconds here. Looks like the majority of it is either roadway or rail utility and others as well. Do that for another 3 seconds here. Okay, great. Thank you for that. I'm going to now launch the next poll question is, what is your current usage level with Civil 3D? And so we'll go ahead and launch that question now as well. And same thing, you can provide any kind of input that you've got. And so this is just kind of getting your comfort level with it. People who are using it every day, couldn't live without it. People who really haven't gotten into it, who played with it, and anywhere in between. So we'll leave that for another 10 seconds or so and kind of get an idea of where most everybody is at on those two. Okay, great. So we'll go ahead and close that out as well. So thank you to everyone there. And we'll move on to the next disclaimer. And so Annie, can you see my screen? Does it show the disclaimer, or are we still on the polls?
You're good.
Okay. Okay, great. I didn't want to trip over that and start talking while we're still showing polls or anything. So as a general disclaimer, anything that we're showing that is promised as future is not necessarily a guarantee that it'll be in the product. So don't base decisions on anything here, but everything we're showing today is actually available in the current versions. So not a lot to get into with that. So everything that we have that we're going to show today, you can do today. So, and again, as we move along, ask questions. Again, we'll try and leave some time at the end to get to those. And so hopefully we can cover any of that. And if we need to, we can kind of take a step back. The presentation that I'm going to show is actually a video, and it does move fairly quickly. And the purpose of that is just we've got a lot of content to cover. And so I may gloss over some topics that you wanted to study and look at in more detail. I may spend some time on areas that you are completely familiar with, and it may be review. So hopefully it's a little bit of both, but I do intend to highlight a lot of the new features that are available in the current version of the software. And as a matter of terminology, some of the different terms that we're going to use in here are not necessarily universal. As far as I'm here in the United States, and so we tend to call things like CANT, we call that EA or super elevation, but in the software itself, it refers to it as CANT. We use other things like ties, cross ties, those are the sleepers for the rail as well. And so when we talk of CANT, it's not talking about the tilt of the rail within the actual fastener. We're talking about the difference between the low rail and the high rail, and that's usually measured in inches or in millimeters. So with that, we're going to go ahead and get started here, and I'm going to launch this video here. And again, as we move along, try and highlight this, we've got a couple different workflows that we're going to look at. The first, we're going to call it a greenfield workflow, and it's essentially it's an extension of an existing rail system that's going to go through some areas that are currently undeveloped but slated for development afterward. There are a couple of different bridges on this particular workflow that we're going to take a look at, as well as some stations as well. The other workflow we're going to look at is more existing conditions. We've got some point cloud data that we have of a station, and it's some very complex geometry. There's a number of tracks. It's a curved track station that varies in width. And so we'll get into both of those. Generally, you're going to have an alignment that was already provided to you. And in this case, we're actually going to go through and lay this out. But this is kind of the alignment that we have. And so a lot of times an owner agency will provide a surface or a preliminary alignment, maybe a 30% alignment. But we are going to show just kind of how to lay out some of that, but we won't spend a whole lot of time in that. I'm assuming that a lot of you are already familiar with a lot of that information. So I've just shown some of the PIs here and just highlighted some of those here. In the new Civil 3D, we've got a rail tab that we can actually create a rail specific alignment. So here we're going to set that up. Going to provide the stationing that we're going to use. We can also specify the design criteria that we're going to use, whether that's the speed or if we have some sort of criteria that we can input. Now, as we get started here, the clothoid spiral is the type that we've got, and that's the default, and that's pretty common as well. In here, we can actually specify the type of spiral that we want to use, whether it's going to be New South Wales, or if we want to use the sine half-wave diminishing tangent, which is really common for high-speed rail. For this particular exercise, we're just going to stay with clothoid. And we're just going to lay out the alignment here using a PI method. So we're going to do that without curves. And so we've got a lot of these identified with these little red circles here. And we'll move down the alignment fairly quickly here. Don't want to spend a ton of time doing any of this. And so as we develop this, one of the things that I tend to do when I'm laying this out by spirals is I'll use the spiral curve spiral technique, and that just allows us to punch in the radius as well as the spirals on each side, and we can do that all the way down the alignment. So again, don't want to spend a ton of time in that particular area, but do want to show that we can set up our alignment there. And so in this case, we're going to have two tracks. We've got a northbound alignment and a southbound alignment. We're actually going to take a look at some of the criteria. Now, if we were working with freight rail as an example, we could set our alignment right there to chord definition. In this case, we're gonna stay with arc definition. We can see that it's a rail alignment, and we've got our design criteria set up. In this case, we're also going to set up our design speeds. We may have portions of our alignment that are various speeds. We might have a tight curve that's insufficient for the full design speed. And so in this case, we can set up those regions here. And I'm going to go down to this area right here. We've got some fairly tight curves through this area. And we can pick that on the plan view and then specify what that design speed is here. And we'll do the same thing. We've got another region just outside of that particular area, and we'll set that point right there as our design speed. And we can set that design speed. We can set as many of these up as we want. We can delete these if we need to, but basically this is set up so that when we run the CANT calculation, it's got the speed to work with. So now once we've got that, we can select the alignment we want to use, and we can actually generate our CANT. So as we do this, good rule of thumb on this that I really recommend, we can see some of the different criteria that are installed here, and you might have different criteria. This is all in English units for this particular model. The other model will be in metric, but take a look at these criteria that are being run. And so if you have different criteria for equilibrium or for your criteria, you might want to input those values there. But this is a fully dynamic table that allows us to revise these values as well. And it's good practice to be able to actually go through and compute the CANT or the EA and the super elevation independently. And that way you can compare it against these, and you can revise both of these values, both the CANT deficiency and the actual applied CANT or the EA. What's nice about this as well is that we can then view that CANT diagram and take a look at this, and it'll look similar to how we set up a profile view. This particular view is completely dynamic. So as we zoom in here and take a look at that, we can see what the left rail is doing, what the right rail is doing. We can see our equilibrium CANT as well. And so I'm going to click on the View Tabular Editor, and I'm going to go to the northbound, and it'll bring back up my CANT calculation. And right in this particular curve, we've got 4.5 inches of CANT that's applied there. If we want to revise that, if we've calculated it to be something else, we need to revise that. This whole table is completely dynamic, so we've updated it there to 5 inches. This is particularly useful, and we'll get into that a little later on for when we set up our track charts. We also have a couple different tools in the rail ribbon for creating a turnout or a crossover. I will say this about the crossover tool as this demonstration goes on, it is somewhat limited, so keep that in mind. There's a handful of different types of turnouts, 9s, 14s, things like that. And so it's not a full gamut of options. You're not gonna have a number 6 turnout, you're not gonna have a number 20 turnout. There are some in between, but it is pretty powerful if it fits for what you need. And so there are some limitations to it. That is in the works to become completely available for all the turnouts. But in this case, once we set that turnout, all this geometry is stored, and we can add to this just as we would in normal alignment. We can add the tangent here to connect to this center track. And I want to point this out. In this particular data set that we've got, on the north end of the track, we have a storage track that'll come into play when we set up our corridor and things like that. And so we've got our turnout set there, both on the top and it's an equilateral turnout. So we've got it on both sides. And right here, we're just going to do a little bit of cleanup so that we can see some of these callouts there.
Ben,
Once we have,
so someone asked, can CANT only be applied to tangent points?
Currently, it can be applied to curves. The developers are currently working on it so that CANT can be applied anywhere, but the way that it works right now is CANT is specific to curves, but like I said, working with the developers, because there were some requests for that, for instance, in Belgium and some other countries in Europe, where they'll need CANT on a tangent section to move out of the way of overhead things, something that may be overhead. That's coming. That's not available just yet, but that's kind of what we've got for now. Okay, thanks, Annie. Okay, so we'll keep moving here. And so what we're doing here with those turnout alignments that we set up, we can convert those into rail alignments so that if we wanted to apply CANT to these turnouts, generally you're not going to do that. You're not really going to have super elevation or any kind of CANT for a turnout or for special track work. But if you wanted to, you could. And so in this case, we've set up those alignments there. All right. Next portion of this is we're going to get into, we haven't really touched on the profile much, and we're not going to dive too far into it, but this is a good practice to use for profiles. What we're going to show here is we're going to set up the profile for this storage track. And what I want to bring to attention here is we're going to do a superimposed profile. First thing we're doing here is we're just setting up the existing profile the way that we normally would. And so we've got the profile for northbound and southbound, and so we're going to show just the existing profile for our storage track. What I want to do here is create a superimposed profile, and so I'll select the profile where I want to put that, and I'm going to actually select the profile that I want to mimic, and then I select the profile to put it back into and do that here. This is really good practice, and so we can see the actual profile location of the alignment for northbound track. This is going to be really useful if you're working on a track yard, or if you're working on multiple track scenarios where you really want to match that profile to a mainline track. And so we're doing that here. We can lay this out with tangents, and it's kind of snapping to some of these points, but we can adjust all of this. But this really gives us something that we can really target, and we can essentially trace that track alignment so that it matches exactly with what we want it to be. That way there's no differentiation when we have special track work or something along those lines. And so we're just matching that up here, and once we get that set, we get that proposed profile set, we can kind of clean up the profile a little bit there. So we're good to go. In this particular scenario, before we start the corridor, we've got a couple different types of typical sections that we've got. Those light green lines represent wall locations, and then we're going to have a couple of bridge locations. We're going to span over that road right there, and so that's the end of a wall. We're going to have a track platform in this area right here, and then we've got a couple of walls again on that side. We're going to span this highway here, and we're actually going to run, because this whole area is slated for development, we're going to have a longer bridge in that area, and then we'll have a platform in this area too. I recommend doing this because as we set up the assemblies in the corridor, those will be particularly useful. And so we'll move through these assemblies right now. So this is the dual track assembly. We can edit the width of the assembly. We can edit the sub layers. Right now I'm setting the track centers to 14 feet. And in this case, we're actually going to sub-excavate out about 3 feet of material. We've got some poor soils in this area, so we're going to sub-excavate that out. And then we're just going to add a side ditch to either side of that. Same thing with the bridge section. We've got a direct fixation rail sub-assembly here, and we're just going to put that on a standard rail bridge right there. And then in this case, we've got some constrained right-of-way. We're actually going to set this up, and we can set the side limits of our assembly vertical, essentially vertical. I set them at 0.01 to 1, and so they're essentially going down. And then we can add retaining walls on either side. The beautiful thing about these retaining walls is they work for cut or fill conditions. And so that's going to be useful anywhere we've got constrained right-of-ways, or where we know we're going to have some of those walls as well. And then here we're setting up our platform. We know that we can set the width, we can set the height, we can set some of the different layers. We can also set the cross slope of the top portion of our platform as well. And in this case, we set these as side platforms. If we wanted to set these as center platforms, we have that capability to do that as well. So once we get most of those set up, what we're going to do now is set up the assembly for that center pocket track. And this is useful anytime we've got a multi-track scenario. So we're going to go to the internal multi-track, we're going to use that one, and set these parameters up. What we'll do is we can control the width of our ballast section, and then the alignment is going to be governed by our profile and our alignment as well. And we're going to do the same thing on the left side and the right side. We're going to do a left-hand track, and in this case, we actually do have a wall on the left side as well. And again, we can control the width of how wide that left side track is going to be. And then for the right track, we're doing something similar as well. And again, I'm kind of moving through this quickly. If we want to get back to this, and if you guys want to take a look at more of the parameters and details, we can do that. We've got one particular section here where we're going to have a wall that we need to draw down to, and I'll explain that a little bit later, where we use a ditch section. And it's going to be kind of a counterintuitive wall layout, but it's pretty typical in some cases where we may have a ditch or a wall that we've got to draw to. So those are our typical sections. And before we get started, what we'll want to do is set up kind of a dummy alignment. And the reason for this is so that we'll have the center of our particular assembly, and we just want it to be in between our two tracks. The location of where it is not as important, because what's going to happen is as we set this assembly up, and we're going to base this on northbound, we can give it a 0 cross slope there. And this is just going to be an offset alignment here. So that's the alignment that we've got right there. And we can do the same things here. We can convert that to a rail alignment if we want. We can add criteria to it. We can add stations or speed zones for that. So we can run CANT on this if we wanted to as well. And this could work the same way. And that's if we know that our northbound and southbound are going to match as far as CANT goes. We're going to do the same thing for the southbound alignment. And the reason why we have these dummy alignments, this is going to give a feature line or an alignment point to draw to for our subassemblies so that we're matching the width of those internal track assemblies that we set up here. And so we're just doing the same thing here. And in this case, we don't want to draw it all the way to the end. We want to just draw it just south of our pocket track, our storage track there. Once we have those set up, we're ready to go and to start to create our corridor.
And we have a couple of questions that came up.
Okay, let me pause before we get into that. Sure, go ahead.
Awesome. So one question was, can you use your own link to shape and point codes?
I believe they're working on that. I know you can do that for, and are they talking for CANT or what specifically for in that regard?
I'm not sure. So Christian, if you could follow up. Oh, for styling.
If it's not I know that's something that they've talked about as well. I know right now for some of those point codes, you can do that in particular when you set up some like the subassembly composer and things like that. They're working on making that more comprehensive as well. So I think it's available now, but it's not as it may not be to the full extent that the user might want to be able to use it at this point. So
right.
that's in development as well. So.
And the second question was, can we lock a distance after the end of the turnout for long common element?
Yeah, and that's possible to do as well. And so I don't show that in this particular layout, but yeah, that's something that you can do as well. So, okay, anything else?
Yes, one last one that just came in. Can we create our own subassemblies?
Yes, you can. And I didn't get into that, and I do apologize just because of time constraints. In the subassembly composer, and that's something that I did. If you noticed on the bridge subassembly, I actually put together a direct fixation subassembly for that. It's fairly intuitive. It's the kind of thing that you draw it from point to point. You can draw the shape of the rail, you can draw the shape of the plinth itself. And then it's the kind of thing that it's fairly simple to do that. For those who have not had a chance to do that but are interested in doing it, Jeff Bartles with Autodesk actually has a fantastic video series on YouTube where he takes you step by step exactly how to lay out a subassembly basically from scratch. And so if you Google Civil 3, or if you get to YouTube and look on his site, you can just search up Civil 3D subassembly composer, and he has like a 10 video series that he walks through that whole thing. It's really pretty slick. So that's something I recommend taking a look at, just because I really don't dive into it in this case. Just didn't have time for it, but yeah, absolutely. And that's going to help with some of these point constraints that some of these guys are talking about as well. So it's there. It can be utilized, but it's kind of it's a whole that could be a class on its own, just because of how powerful of a tool it is right there. So. Okay, so now we're going to get started with the corridor model itself. And so we're going to use that dummy alignment that we set up kind of as the baseline. Again, we don't really care about the profile or where it is, just it needs to be in proximity of our rail alignments, but we're going to use that just kind of as a guide. And so right here, it's going to go from the beginning all the way to the end of the alignment here. So we've got, and it's going to have just the one assembly. And actually, we're going to use the walls in this case rather than the LRT, just the regular section there. We can set up our frequency of how frequently it draws these templates out. We'll keep that there for now. And then in the target, set this up early on, because this is something that can be a little bit tedious. We're going to search for the northbound track for our left track. And on the right track, we want to pick our southbound track. And that way, when it draws those rail assemblies, the rail and the ties, it's going to go right to that location. So it doesn't, there's no differentiation between that and our alignment. And we're going to select the profile in this case as well. So the southbound profile for the right side as well. And then the walls, we'll get to that a little bit later on. But once we've got that set, what we're going to do is we're going to break this up into regions. We're actually going to divide regions here. And that the reason we're going to do that is because in plan view, we've already drawn out where our wall locations are and our bridges. So we're going to select split region, and we're actually going to pick that storage track area, both the north and the south part of it. And then we'll just move down the alignment. We're going to pick the different locations of where those walls begin and end. And this is going to set up a number of different regions for us that we can then specify how exactly we do this. And so there's a couple different ways to do this. You can add regions one by one. In this case, it was just simpler to go through because we had everything drawn out already. And so we've got a number of regions. All the station locations are drawn out the way they should. And it's going to default to that assembly that we chose early on. So if we want to, we can change that. And so we get to some of these station areas, and because, as we get familiar with those station locations, we can see, yeah, we want a wall just on the right side. Right there, we happen to be using a bridge. We know we've got a bridge in that location. And then we might know where our stations are. And so as we populate this whole area, that's we can tighten up our frequencies here. We're doing that there. We can check we can set the targets and check those later on as well. But this is gonna allow us to just set up the entire model, again, based on that dummy alignment. We'll add a couple different baselines a little later on, but for now, we're gonna run the corridor and just take a look at what it's given us. And so we've got walls on either side there. It looks like it's pretty good. And we can just pan through the alignment and see if it's something that we expect. If we were expecting a bridge in one location, but we see cut fill, we know we need to revise that. And then right up in here, we can see that storage track. We don't have anything for that modeled yet, and so we'll do that now. So all we do is we select the corridor, we right click and select corridor properties. And in this case, we've got that region. I'm going to toggle that region off so it's not running the alignment through there. And then we just add a baseline. And in this case, we're going to add the storage track. We're going to add the region, and we're going to select that region that we created. We called it store center line. So it's going to be that middle track. And it's going to run from the beginning to the end. And again, we'll want to set our targets here. And the targets we're going to select are that left edge. That's going to be the dummy alignment for the left edge of our alignment, or for our template. And the same thing for the right side, so that our assemblies know exactly where to draw to. And we'll do the same thing for the left and for the northbound and the southbound rail. And so when we run that again, pan out a little bit here, we can see exactly where that drew. And we can do the same thing for this, and we did the same thing there as well for our turnouts as well. We ran that just with the center track assembly there, and then we run the whole thing, and those fill in as well. So again, kind of gloss over a lot of that, I know, but what that did is that just set it up so that we have our entire assembly. Now this is that area I was talking about before. In this case, it just found existing ground, but we know in this area, we have a bridge, and we actually want to create walls in this area because this whole area is slated for development. So we want this actually to go down to an existing alignment. And we actually have some data shortcuts for a couple of alignments for these MSE walls that were created outside of this drawing. And so those represent just the edges of both of those. And so we can import those as data shortcuts, and those are just simple alignments and profiles, and that's all those are there. And this might be pretty typical. We might have a ditch that we've got to model to. We might have a wall height that we know we have to hit for something that's going on, and that's the case in this area. This is a whole area slated for development. We can look at this profile as well and see this is the proposed bottom of the wall there. And so we want our model to go down to that point and then cut out up to existing ground. And so in that area, that happens to be right there. And we're going to select our MSE ditch. And that's the name of that section that we get. And in this case, we do want to model our walls down to those proposed profiles. And we're going to pick the left and right profiles on both of those walls there. And we say add. Okay, and then once we're good there, we hit OK, and it runs the corridor again. And then when we model that, we can see that did what we wanted it to. It went down to that profile, and then it's going up at a 3-to-1 most likely to find the existing ground. Now, once we have our entire corridor set up, good practice is there's a couple different ways that we want to visualize that. One of these is we're just going to go to the section editor. And so this will take us right to the beginning of our alignment. So we can inspect that, and we can see right here on the right side, we're missing a wall. So immediately when we look at section view on that right side, it looks like in our corridor, we missed something. So we'll go to that assembly, and that's actually in our baselines that we added. So the right side, we're going to go to that assembly, and we're going to go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that assembly, and that's actually in our baselines that we added. So we'll go to that Yep, and that's exactly what we did. We didn't select the existing ground to find that wall. And while we're there, we'll probably just add the left side of our, and that's of our multi-tracks layout, so that we're drawing exactly to that. We hit OK, we rerun the corridor, and then as soon as that comes up, we can see there's our wall. We've got our wall on the right side now. And so this is a pretty powerful tool that allows us to inspect and go through. We can jump from station to station, and we can actually change the different baselines. We've got a number of baselines that we're using in this corridor that we can change the baseline and then go to different stations that are along here. And so let's jump ahead to one of the bridge sections here, so we can take a look at that, how that ran. And that looks to be pretty good. Let's zoom out just a bit on the section view. And the thing I like about this is going to show us where we are in profile, where we are in plan view, and what our template is for this particular area as well. And so we can see the platform that we drew in here. We've got side platforms, look to have drawn pretty well. Looks like they're pretty consistent with our existing surface there. And let's jump ahead to that area that we created where we had those walls that were going down and then cutting out through the existing surface. So we have a bridge into that, and we can see that these ran pretty well. That did basically what we wanted it to do. We had a set elevation for the bottom of our wall, and it looks like we're in pretty good shape there. So
Ben, we have a few more questions.
Sure.
So one person asked, at what point do you go ahead and edit your styles?
I don't get into that as much here. Again, that is a whole different, not a whole different topic, but when we get into like, and I assume they're talking the settings and the styles and things like that, a number of the settings that I'm using are basically out of the box settings. Those can be customized to look exactly the way that, you know, the agency you're working for, the consultant or whatever it is, those can be styled exactly that way. I can touch on that a little bit later on, maybe outside of the demonstration, but I don't really get into that. And I do apologize, I don't really get into that too much here, other than we're basically using kind of what's out of the box, so to speak. So I do apologize. We don't get into more detail on that, but again, just because of time constraints, that's kind of, we're just showing kind of what's available, kind of on a higher level as far as that goes. What was the other question?
Another question is it possible to lock a region to a geographical location instead of the station location?
Not yet, and unfortunately, not yet. We had some guys that we've been working with who've been requesting that as well, and that's something that the developers are working on, because that might be an area in particular where they know they have a station at a specified location. They're working on that to get that, and they're also working on edge of platform calculations. And again, apologize, you know, that's part of the disclaimer. You know, don't make future purchases based on stuff that I'm saying, but I know for a fact that is something that they're working on, but not just yet. That's not quite there yet.
Another question was, for PKT files, do we have to do this, or is there another way?
And for PKT files, those are going to be those subassembly files that you bring in. Do this. What do they mean by do this? Just as far as setting everything up in the corridor as well. It's going to function. Those PKT files are going to function very similar to the way that those out of the box subassemblies come in. User, if you've got more questions on that, type of follow-up question, because I'm not exactly sure, but I think that's what you're getting to. But yeah, those will function the same way as when we set up our corridor. We can add those in, you know, however we need to, and those should function pretty well. Okay, in this next what I'm going to do through this area is set up a drive surface. And again, I kind of moved through this fairly quickly. We're going to create a surface from our corridor, and it's going to be basically based on all of our top elements, our cut fill lines, the top of our deck in that ditch or in the bridge section, and then our ballast. We're going to use all those values, and essentially all we're doing here is we're creating a finished surface, and then we're going to add an exterior boundary to that. Once we do that, this is a dynamic surface that will update with the corridor. And what we want to do here, just take a look, we can visually inspect to make sure that we've got everything we want. It looks like we do. And so with that surface, we want to create another surface, and this is going to be a dummy surface for our drive command. And all we do here is we can paste in our existing ground surface into that surface and then create a hide based on that proposed surface that we just created. So we'll select that corridor top there. And now we go through, we can turn off our original surface and we'll turn off our corridor top as well, so that the only surface that's showing is our drive surface that we just punched a hole through, essentially, and so that we can see our corridor when we do the drive itself. The reason why I recommend doing this is because this is going to be the best and fastest way. Visually, it's kind of cool, but what it's going to do is it's going to tell you if you've got any busts in your corridor. You're going to see if something completely missed, if something didn't run, if the left or right edges don't quite work out. In here, we can see we've got 30-foot track centers, but as we go through this curve, it narrows down to 14-foot track centers. We'll want to inspect that, and that looks pretty good. Our bridge looks to be in pretty good shape as we go over it. And again, kind of on the left side, we've got the existing surface. We may have punched a little bit too much of a hole in there, but for the most part, it looks like everything seems to be in pretty good order. We go all the way down to the end of the alignment through the platform and to the very end of the tail track. So the reason I recommend doing that is just so you can get a visual inspection of what you've just created with the surface model there. So the next thing we're going to do, and again, we'll move through this fairly quickly. We're just going to set up our sheets for our sections, and we'll just draw the pattern lines. I know this will be a review for a lot of you, if not most of you, but did just want to show this to a number of those who are just kind of getting started. And so if this is something you want to set up, we're just setting up sample lines. Again, basically what's set up in the corridor. We've got 50 feet on either side, and then we're just going to use that and basically the standard layout for our cross sections as well. Again, you can really get into these and show a lot more detail than what we're showing here when you set these up with your settings and set up those styles a lot better. And here, these are kind of straight out of the box. I don't love the way these surfaces look or these sections look, but it gives us a chance to inspect. Here we can see we've got some pretty steep cant right there. We might want to go back and revise that. We can inspect the bridge section here. Looks to be in pretty good shape. And the nice thing about these sample lines is they are dynamic. If we want to adjust these, if we want to make a section wider for whatever reason, if it was a really wide cut area that we need to show more of the section on, those will update as we update those pattern lines as well, those sample lines. So just did want to spend a second or two on that. We can kind of see that our CANT did run when we did that. Next portion, what we're going to do, we'll do the volume, and we'll set up another surface as well. This time it's going to be more with the bottom section of our particular surface. We want to set that up with our sub-base layers, and this is going to really help us to when we get our quantities estimate, we'll want to have that for this. And so we can inspect that again in our section viewer. We can see that's our volume surface. It goes above that subgrade level, and then we can see the difference between the top. The top is going above the ballast there. And so we'll select that surface and select the volumes dashboard, and then we'll create a separate surface that basically estimates the difference between these two. It's going to look at the base surface of our existing and then that volume surface we just created. And then it will quickly spit out, and this is a real quick and dirty idea to give us an idea of what kind of earthwork we're looking for just based on the two sections of the two surfaces that we created. If we want to run volumes here end to end, we can do that as well using those pattern lines that we just set up, those sample lines. And so we'll do that by computing materials here. And then once we've got that, we'll go to that materials list. And we've got a couple different options here. We could do mass haul or earthwork. In this case, we'll just do it as an earthwork. And we'll display that XML file as well. We'll select OK. And this is going to give us a section by section rundown of what our volumes are going to be. And there at the bottom, we can see what our total cumulative is going to be, and all this is shown in English units. Again, it would be in metric if we were running in Civil 3D metric, and we can copy that, paste that right into an Excel spreadsheet, create graphs out of that, whatever we need to do. We can also create mass hauls out of that. This is all basic the stuff with running our volumes report. In the reports manager, I really recommend kind of 3 different reports that we can do. We can select the alignment curve report. And so we're going to pan down to, we want our northbound alignment. Let's go a little further to the northbound track right there. So we'll select that and we'll hit OK. And we just saved this out as a civil report. We can save this as an Excel sheet. And this is going to give us all the curve information that we're going to need, and so we can use this in our geometry reports. Because this is an Excel file, we can do anything we want with that, move it, you know, and customize it how we need to. And we're going to do the same thing this time with the station and curve report. But what this is going to do, this is going to provide a lot of the information here. We'll save that as the station there. And this is going to provide our points. This is going to provide northing and easting points for our tangent to spiral points, our spiral PI, our curve, spiral to curve points, anything along those lines. That's going to give us that information. One other thing we can do is when we select the alignment and go to edit geometry, this table will come up, and we can specify just by right-clicking in that top area, we can specify what parameters we want to show, whether it's our short tangent, our long tangent, our p-value, our degree of curve, whatever it is that we need to specify there. We can show all of that, and then we can select this whole entire thing, copy it out, and put that in a spreadsheet as well.
Ben,
I
one
will
question
say
on
this.
reports. Sorry.
What's that? Go ahead.
On reports was, can you create a report for surveyors? So looking at coordinates of edges and levels.
Yeah, those are available as well. The reports that I'm showing in this demonstration are more for geometry tabs, but yes, those are available. You can do, there's a handful of different reports where you can do staking reports and offset reports and things like that. All those are available, particularly, you know, for when the surveyor is getting out of the field and has to stake the center line, things like that. A lot of this information can be pulled into that. And again, I'll say that they're also working on putting this together to make this more customizable for the user, so that it looks to be in more of a format for geometry reports. The reports that I go over in this case are more for when the designer is creating like the geometry tables, and so a lot of this information can be pulled from there and then specified. A lot of the legwork does kind of have to be done in Excel, but that's in the works as well. So, but all this can be pulled from here right now. So. Okay. So once we get to that point, we've got a couple different tools that we can utilize here. We're showing the CANT in this case, and the CANT tables show us the station locations as well as their height. In the profile itself, we can set up a band. This is something that's pretty straightforward. We'll just select the profile properties, and we go to bands, and we can select our horizontal geometry. And basically what we can show here, and again, a lot of this is customizable, so it can look and feel exactly the way that the agency that you're working with needs to. And we add that as a band, and then in the lower area, we can demonstrate and show our horizontal geometry. And it's going to show where we have spirals, it's going to show where we have our curves, it'll show the length for each one of those. And this is particularly useful, and it'll show the curves just as a straight line down. And so we can show these anytime we need to get into to demonstrate what we need to show for a track chart. So that's just kind of a basic and simple way how we can set this up. This next portion is a little bit of a teaser, and I'll pause just after this demonstration, but this is kind of a teaser for 2 weeks from now. Once we are done with our alignment, we can take it into InfraWorks and set it up, and we can set these up as customizable component roads, essentially. Right now, it works better as InfraWorks works better as a component road. And so we can specify, you know, putting in some track and things like that. But this is a pretty cool workflow that we can work with structural engineers. In this case, we lay out the limits of our bridge, and I just grabbed some arbitrary points right there, but we can specify that to lock that in exactly to where we need our bridge to begin and end. And then it's got some pretty cool features as far as specifying how we can set up what those assemblies look like. And I've got a custom assembly here that is for a direct fixation bridge, and we can specify the limits there. We just drag it to the end here. And so we can set this up as a really cool you know, visualization of our project here. We can kind of look around at this and look and see how this looks to be in kind of a 3D environment, and then we can add any kind of features that we want to this. In this case, we added some rail on the side of that as far as a fence. If we want to add the OCS, in this case, we've got overhead catenary poles. We can add those as well, just as a feature, and we can revise the spacing there. We've shown that as 105. We also have the ability, there's a lot of, and Ara will get into this next week for those who are interested. But again, this is just to kind of show we can adjust those columns as we need to. In this case, we're showing a column in the middle of a road. We don't want to do that. So let's slide that over. Probably put it in the median right there, I would think. Once we've got that set, once we've got our bridge laid out, we select the bridge and we right click and we can send that to Revit. And the really cool thing about this is this will immediately open Revit. So we hit create. It takes a little bit longer than what I'm showing here, but not by much. It may be a minute or two, and it'll bring up this model right here in Revit. And we can look at it in 3D, and it's going to show and contain everything that we put in that InfraWorks model. It's got our foundations, and again, all of this is editable within InfraWorks if we want to change the style of our, of our bridge, whatever it is, whether we want a tub, or if we want girders, if we want, where our OCS poles, or what our bridge piers look like, we can change and edit all of that. And once we've got it in Revit, and this is just kind of showing just a simple workflow, we can select that, and this is a slightly different bridge pier, but the concept is the same, where the structural designer can go through and add anything that they need to in regards to their rebar details. And so this whole thing, everything within Revit at this point can be designed within it right here. We can create cut sheets from here. We can show the full rebar details, quantities, anything we need to at this point. So I'm going to pause right there. The next portion that we're going to get into is that existing alignment that I talked about. But Annie, are there any other questions or anything like that that we want to touch on?
Yeah, we definitely had a few. So one was, how do we create a TIN surface from the rail assembly to create a grading plan showing the top of a ballast or the top of a sub-ballast?
So that's going to be through the, and I again didn't get into that much, but when you set up the surface from your corridor, you can do some revisions through it that way. There's some conversion methods that you can take your surface and create a tin out of that. But again, you'll select those features that came from that assembly, the top of ballast or the top of sub ballast, or whatever it is that you need to use. With that surface, you can export that out as a tin file. Again, I apologize, didn't get into that as much, but it's something we can kind of touch base later possibly.
Another question is, are multiple corridors in one section stable?
They are, and that's, and so you don't have to run multiple corridors per se, but multiple baselines is what you can do. And that's the beautiful thing about the way that the corridor model is set up. If we've got, and I'll show you in this next model, we've got 10 to, actually, I think in this case we had 5 sub-tracks, a storage track, and then 2 main lines. So we've got, 7 or 8 different tracks and different alignments in one corridor, and it is stable. It does maintain itself. Essentially, as long as we've set it up right, obviously the bigger and more complex our corridor get, the longer it takes to run. But rarely have I ever seen any kind of problems with it being unstable. Other CAD platforms that I've worked with before, if something is selected wrong or whatever it is, it kind of blows up. But fortunately, Civil 3D has been doing this for quite a while, and it's still kind of running off of the same technology that is very stable, which is nice about it. So.
Okay, we have a bunch of more questions, but maybe we do 2 more for now.
Okay.
Another question was, what's the best approach when you want to adopt a number of subassemblies in one alignment?
So what I did there is I had, as we kind of showed, I think I used probably 6 or 7 different sub-assemblies. Really, the sub-assemblies, the best approach is have a sub-assembly for each kind of typical section that you're going to use. You can use dozens if you need to, and that's the beautiful part about it. But if you've got multiple tracks, like in a yard, like I showed, if you need to run just like an internal track, that's kind of a best approach there. But if you've got a 2-track alignment that goes through a number of different things, whether it's walls, whether it's ditches, whatever it might be, I recommend having a subassembly that matches each of the typical sections that you've got on your project, and those might have to be developed as the project goes along and as the corridor is developed as well. So.
Great. And then the last question for now, going back to reports, was that the person expressed that Project Explorer needs to be used to have enough information. And the question was, will there be any composer for reports?
Good question. I don't know the answer to that right now, but but from what I've heard them talk about, that's the direction that they want to go with it. They want to make those reports as customizable as possible, so that when you're doing it, you're not having to take from 3 different reports to assemble, one data set, so that you can show your geometry sheets. They want to make it so that you can have everything in one report that's giving you the exact detail that you've got. So I think so, but I'm not exactly sure on the methodology that they're using for that. And I do apologize, guys, if I'm not really answering your questions as clearly as you'd like. It's in some of these cases, the answer is yes, but it's still kind of in development. In some of these cases, I just didn't have time to show it, but it is possible. But just due to the amount of content, trying to get through this. Any questions that anyone has later on, they're welcome to ping me with, and I'll show some of that information later on as well. But we'll get into the second portion of this, and this is that data cloud, that point cloud that I talked about previously. This is a fairly complex model, and this is showing recap. This is just kind of showing how we can view some of those points that we bring in. We typically have an LAS file, mobile LiDAR, something like that. We can bring in a point cloud for. And in InfraWorks, once we've got this set up, we can consolidate this data in recap and bring that directly into InfraWorks. And InfraWorks has a pretty cool feature called linear feature extraction. And what I can do is literally just trace the top of rail through here. And that's what I'm doing in this case right here. I'm just tracing where we've got those density, those points for the top of rail here. And I haven't done them all here, but then we can create cross-section lines. They're called transverse features. And we can export this data into Civil 3D so that we can work with these as 3D line strings, and we can create our surface from those as well. And so we're going to create a linear features. We're going to import those, and those are going to be break lines for our top of platform. And I'm going to color code these slightly different. The red lines will be the platform lines, so we can kind of tell what's what. And those blue lines are just the top of rail line. And one thing that we can do is we can convert these. We can either leave them as is, as AutoCAD features, or we can convert those to actual feature lines. And here I just call them rail features. And yeah, we'll erase those. Select OK there. And so those convert into actual feature lines. And so when we go in and we can create a best fit alignment for those, we can select either Koga points. So if we've got survey points, we can use Koga points. If we've got feature lines that we know we can use those too. And in some cases, you might have to play with these values as well. The maximum radius, and I'll get into that a little bit more. But the nice thing about this is that we've got a number of different types of spirals that are supported in these best fit alignment. That was a new addition to Civil 3D for this particular. So we're going to select just the left rail here, and that's going to be our point 1. Path 2 is going to be our right rail. And once we select those, we're going to hit OK, and it'll run a regression analysis, and it'll bring up this table. It'll show us exactly how far, from to the left or right from those lines that center point is, and we can pan through and we can see our values. This is all in metric now, but we can see our values 0.002, 0.016. We're really close, and so we can look at that alignment and see that it's right down the middle. So this is certainly going to be faster and better than anything we can come up with on our own. And it's a pretty quick analysis. The nice thing about this is we can edit these alignments that we receive as a result as well. Those are something we can fully customize. We can do the same thing, and it doesn't have to be with a feature line. Again, we can do it with Koga points, or we can do it with AutoCAD entities. And in this case, we're going to use these 3D lines. We'll select the left and right rail and play with these values. If it doesn't work, sometimes you might need to play with the RA factor there. You might need to modify those values. I've noticed in some cases, most of the time the values that are in there will work pretty well, but you might have to play with those values just a bit if you're having a little bit of trouble getting it to run the way you want to. And again, we can view the regression analysis output and see kind of what we've got as a result. And we can go in and inspect that alignment, see what we've got. And it looks like it's really good. We're right down the middle. Looks like we're in pretty good shape. And again, this is going to be a fascinating. We've created a spiral through there. Sometimes it will create broken back curves with us, and that's with what we've got, and that's one thing that I'll show here. In this case, it didn't create a curve through this portion. It created the 2 tangents. And so there's a bit of an offset, but again, we can revise these alignments however we want. Just as this one worked out, I wanted to show this one as an example because sometimes we might have something where it shows, just the tangent in and out of our particular curve. In that case, we still have the ability to edit this alignment. And it might have been some of the values that I selected early on that had, that it was finicky about, whatever it might be. Generally, it works out really well. But like I said, if you need to play with some of those values from time to time, you can do that. And then you can always edit the alignment afterward. What I recommend is inspect this, see if there's any kind of broken back curves that you need to get rid of. But once and I've done that with all of the different alignments that we have through here, and we can turn on our geo reference map to take a look and see where we're at. It looks like we're in pretty good shape. And so once we've got that, we're going to do the same thing with the profile. And we'll take a look at, and we'll do it the same way. We'll do a best fit profile that's going to be based either on those feature lines or those AutoCAD entities as well. And we can also use Cogo points as well. In this case, we're just going to draw out the alignment. We'll inspect that. Looks to be in pretty good shape for our existing ground. And then we're going to select the best fit profile. So for this particular profile, we're going to select feature lines down there. And then again, we do the same thing. We're going to select the left rail for one side, and the right side, we're going to select the right rail. And what this is going to do, and we want to do this as a trend line. We can do it above if we want, but in this case, we'll do it as more of a trend line. So it's going to be above and below. We'll call that our proposed mainline track 1. And once we hit OK, we can do the same thing we did before. We can inspect that profile. And as it comes out, we've got a couple different points in here. We can actually edit the profile geometry. In this case, we're going to remove a couple of points and lengthen some of these vertical curves. And it looks like in this area right here, we probably need a bit of a sag. So we can add points right there. It's going to give us a nice trend line. And what it's done, they've revised the way that the regression analysis works so that it's not giving us 1,000 curves up and down all the time. It's going to try and give us the best possible trend line that we can. And we can go back into those features as well when we set that up, and we can make it more so that it models exactly with what we've got in our elements. And so here we're just inspecting the profile that we've got. So for this next portion, we'll do the same thing. We can calculate the rail, and what we'll notice, and this is one thing you might run into, when we're calculating CANT, and this is the metric equation here, but when we calculate CANT that was based on some best fit alignments, we might see that we've got a couple different issues right there, and it'll tell us, hey, you might not have enough, you don't have enough transition between these points, or the transition between this is really tight. In this case, we can take a look at that diagram and we can edit this as we need to. In this case, we've got a broken back curve where we have 25 millimeters of CANT. What we're going to do is we can either revise the alignment, or this gives us the opportunity to revise the CANT through there. And so we're just going to maintain 25 inches of CANT through that alignment. In this particular model, we're just going to run a skeletonized track. And these the assemblies, the way that they're set up, all I have to do is tell it to turn off ballast, and the only thing that it'll give me is the rail and the ties or the sleepers. It's doing the same thing here, omit ballast, and just say yes, and now I'm just going to run this as a skeletonized track. That's kind of typical when we're modeling something that is an existing condition and where we may have just some general realignment, and maybe they're going to come in with ballast later on after the track has been realigned or shifted one way or another. But this gives us a good model that we can kind of work with. And again, we'll add a baseline, and in this case, you'll see kind of, I think we had a question on that earlier. We'll do the same thing here. We've got the dual track scenario where we're going to pick the left and right rails as mainline track 1 and mainline 2, and we'll do that for both alignment and profile. But then we can add baselines for as many alignments as we want. And we're going to do that. We're going to add an alignment for, this is track number 4, for instance, and we can specify we just want that single skeleton alignment through this. So we'll go skeleton single right there. And we'll do that for all the rest of our alignments throughout this particular corridor. And so in this case, we've got 9 different alignments that we've added to this particular corridor. And we want to make sure that we specify those profiles here. I had forgotten to do that in this case, but we'll go through on each one of those. We can change the frequencies if we want to make this really tight. We can make that as tight as we want. And we can verify our targets to make sure that we're finding existing ground wherever we need to. And once we run that, we've got our skeletonized model. and we can create surfaces from this. We can use this in a number of different functions. One thing I didn't point out, but what we can do, we don't have to have just an alignment. And here we have feature lines for our edge of platform. If we wanted to, in this corridor, we could also add the platforms as a portion of that corridor as well. Again, I love this feature because it allows us to inspect exactly what's going on with this. And we can see at a turnout, our elevations are off. And so again, I do that superimpose profile here. We're gonna do that for track number 4. And basically right at that point of switch where we would have, where we would want those elevations to be exactly the same, we're gonna demonstrate, we're gonna show what mainline track 2 looks like right there. And we're off. We can see right there that, you know, when we brought this profile in, we need to adjust it just a bit. And so we can do that here. We've got the ability to adjust any of these profiles, and our corridor will update automatically as we do that. We can either set it to update automatically, or we can update it when we tell it to. But in this case, we match that profile, we run the corridor again, and then as we inspect those features where those ties are, and as we pan through this, we can see those are a lot better. Those elevations are a lot more concise with what's going to be happening anytime we've got some special track work or a turnout of any kind there. And then we can go through and do the same thing. We can inspect this, visualize some of the things here. We've got our platforms there. Just verify that everything looks to be in pretty good shape. And again, I do the drive command. I'll pass through this quickly. I imported the larger surface from InfoWorks that will allow you to do that. And that was just so that we could see what was outside of these boundaries. But again, really the purpose of this is to be able to inspect our corridor. This is going to tell us if something's blown up, if something didn't find existing ground, if it didn't model quite correctly, if there's something that's going, you know, off to somewhere. This just gives us an opportunity to really look at it and quickly pass through this without having to go station by station, which we can do that too, but this allows us to quickly kind of move through the corridor and see exactly what we've got. Again, sheets, we've shown that before, another opportunity to inspect what we've got. As we move forward on this, I think there was one section that we got to, I think it's 10 plus 800. When we look at it, it looks like, yeah, one of the rails is off. We'll probably need to adjust that. Yeah, that one right in the middle there, looks like we'll probably need to adjust that up, but we can do that in the same way that we've done before. So, all right, as we move through this, and we're just about done with this particular one, this is a surface that was created from that corridor. And so once we've got our surface, we've specified the range for it, this is something that we can export out into Revit. So if we're working with you know, our architects, the designers for the platform or the station, whatever it may be, we can actually provide this surface to them. We have a collaboration feature that we can export this alignment out, and I'll move forward just a bit here. And we do this all through BIM 360. We can kind of show how this works. But once we have that in Revit, that surface is going to be geo-referenced. It's going to be in the correct location, which was one thing that I knew was always a challenge, to make sure that everything was in the correct location. But we can see, you know, we can start adding features to show, you know, our rails there. But this is something that, again, we can provide this data, export this out, and get this to our designers as well. All right, with that, I know there's probably quite a few questions. We are at our time. We are at 11 o'clock. So if anybody does need to drop off, and I know a number of you may at this point, you are more than welcome to ping me with any kind of questions, and I can provide my email address up here. But I want to inform you guys of next week, not next week, but 2 weeks from now, the InfoWorks 19.2, and Ara is going to go over a number of that. For those who want to stick around and who do have questions, we can certainly hang out for another 5-10 minutes. And I do apologize for the length of the presentation. I know we had a lot to go over, but Annie, I'm going to open it to you for questions we have. And again, guys, if we don't get to the question, we can take a look. For anybody who has submitted questions, we can go back and review those, and we can follow up on those as well.
Yes, and we can send you a direct email if we didn't.
That's right. That's right. And again, and I apologize for those who have submitted questions if I didn't answer them in the way that you were looking. apologize for that, but you know, we'll try and cover those as much as possible. But let's go forward with what we've got for the next couple of minutes, and we'll just answer as many questions as we can. Thank you to everybody who was able to participate. I do understand if you need to drop off. Thank you for participating. And again, this will be posted on the civil community site probably by the end of the day.
Great. So we have 5 questions. The first one is it possible to create a polycentric curve with more than 2 circular curves?
So I think, yes, you can do that. You can do a compound curve. And that's something that it takes a little bit of manipulation, but in laying the thing out in Civil 3D, it is definitely possible to do that. I'm not sure if that's exactly what they're getting at, but it adds a level of complexity for the geometry. But once the geometry is set, the corridor can manage it just fine. But yes, I believe so. Maybe not quite to the extent that that the user might be hoping for at this point, but yeah, it should be.
And then back to ballast codes. Does the top of the ballast code on the rail assembly stop at the edge of the ballast?
So let me bring up Civil 3D here, and we'll show a couple things. So we can specify all of that. So as far as the ballast codes go, so we've got an edge of ballast right there. And this is the problem with doing live demonstration. All these are our different codes. We can specify exactly where those go to. So for instance, if I wanted to edit how wide that left shoulder ballast is, I can do that right here. So on the left shoulder, I've got 1 foot right now. If I wanted to make it 3, put that right there, then that updates automatically out to 3. So that can go wherever we need it to. Currently right now, it's not set to go to, and the assemblies are in development. So if we had like a feature line that we wanted to draw this particular model doesn't, or this particular assembly doesn't go to a feature line, but the center track option will do that. But in this case, we can set, you know, what is the width to our wall or to our edge of whatever it might be. We can set that distance, and all these parameters are editable within the assembly itself.
Great. And then for geo-reference maps, will it ever be Google-based again?
I hope so. I don't know. I know that for a long time we were working with that, and this is above my pay grade. This is for people who are, you know, making, you know, brokerage deals and things like that. Right now we're using Bing Maps. I know that for a while we used Google Maps. I don't know what the plan is, but I know that's an ongoing discussion. So it's a possibility, but for now it's Bing, and I don't know of any immediate changes coming up.
All right, 2 more questions. We have the next one, which is it possible to add or exclude points in the best fit window report?
You can, and that was part of when I went through the annotation. Let me get to the rail ribbon, or actually to, so this one's not the best fit analysis. You can do that. What I would recommend is if there are points that you want to exclude, you might want to do that on the actual 3-dimensional line itself or on the feature line. And that there are ways that you can remove those points. But you do have the opportunity. It's called the weeding factor. And let me see if it comes up when I do best fit. So we do a best fit alignment here. And so when we get into weeding options, that will allow you to go through and you can select points that you want to exclude. If you know something's way out of whack, something is, maybe that's the reason why you're doing a rail alignment to begin with, is that you've got this whole region that is out of whack and needs to be straightened, and you don't necessarily want to follow that. There are methods that you can do, and it's under the weeding options that give you that opportunity. So.
Great. And the last question is, what's the fastest way to edit your daylighting or super elevation other than going through this section station by station?
So I would visually inspect. The fastest way that I would recommend is to go through and look at your corridor in plan view. If you've got something that looks to be out of whack, if you know of an area in particular that you've got a problem in, you know, if we look in this area and see, you know, okay, something's out of whack there, we can jump immediately to that section. the corridor, you can handle that as well, but that would be the fastest way that I would recommend. Just from a horizontal inspection, that's going to be the fastest way to get to that. But that might not be what the users has in mind. But there's a couple different methods that we can as far as getting to that. But the concern I can imagine, it may be that we don't necessarily know what we don't know. As we go through the alignment, it does take some time to kind of wade through that, and we may not discover something until the very end of the alignment, and it's that's kind of a long process to get to that point. Unfortunately, that's kind of the methodology for it, but that would be the recommendation that I would give. So, any other questions? We've got probably one more minute, and then we'll probably go ahead and stop. But again, thank you to everybody for participating, for your questions, and again, for those that we didn't get to, and if we didn't answer your question satisfactorily, let me know. Follow up, and we can certainly provide more of this information to you guys as it goes on case by case. Good luck in your project as well. This is kind of a fairly quick and dirty way of doing this, but very powerful tools that are going to help get through this whole rail design process, and a lot of these features are going to be very valuable to getting to the point where you guys want to be. So with that, guys, appreciate it. And anything else? Any other last questions or anything like that we want to cover?
I'll just say that you guys can email us at civil.community@autodesk.com, and we'll follow up through an automated email from GoToWebinar as well. So we'll be sure to find a way to connect with you directly. We did have a few questions that were more along the lines of feature requests and things that are above what Ben and I can answer. We also had some great feedback in terms of topics that you'd like to cover.
But I'll say this, with future requests, we love that information, so submit it. Absolutely. If there's something about the software that is driving you crazy, it's like, why doesn't it do this? It should do this. Let us know. We absolutely, I know when we work directly with a lot of the developers and things like that, and these are the kind of questions and input they absolutely want and love to hear. They want to hear when a user is coming across something and has a suggestion for an improvement or whatever it is. Please provide that information. We will take note of it, and they have a whole roadmap for things that they're planning on doing in the future that we can certainly add to that. I touched on a lot of a handful of things that they're planning on in the future, but a lot of that is driven by the user experience as well. So if you guys have thoughts, suggestions, things that you would really like to see improve, please let us know. Absolutely, and we can incorporate that.
Great, sounds good. And as
thanks very much.
Leaving, you'll see a survey, so if you could help us with some input, that would be great.
Okay.
Great.
Thanks, guys. I'm going to go ahead and shut it off now. And again, want to thank everybody. Have a great day. Take care, guys. And we'll have this up probably in the next several hours on the Civil Community site for if anybody that you know of missed this and would like to take a look at it. Thanks very much, guys.